Will we need to be all in front of this one presented?
Yes, please try to do that. Yep.
Perfect.
Sure. Yep, it's recording.
All right. So we are the 60 sub project group for M2I. My name is Jack Thaliker, and I'm the team leader for this project. I am a sophomore in aerospace engineering.
My name is Nathan Chapdelaine. I am a freshman in aerospace engineering.
I'm Ryan Drexel. This is my first semester in aerospace engineering.
And my name is Brandon Baxter. I am a sophomore in electrical engineering.
And then this is all our first semester on this project. So our project objectives and mission will be shared.
So our objectives is the 60 sub stands for 6 dimensions. So we're able to move back and forth along all 3 axes. If you saw in that design, we had 6 propellers total, sort of a cube spherical design. So our objectives is to design this unique motor setup for an underwater vehicle. Unique in the sense that unlike, say, a traditional submarine, this doesn't use any kind of rudders to control. It's entirely 6 separate motors. So that's interesting to work with. And through this, we hope to gain experience in the design and programming of, again, an alternative vehicle control system. We hope that that kind of different perspective, kind of an exotic engineering, we hope to gain from that. And in the end, we also hope to be able to submit our design to compete in an underwater vehicle competition, which you'll see later on.
All right, for the 60 subgroup, we have some short-term and some long-term goals. In the short term, we want to take the vehicle prototype. We want to take our current vehicle prototype to a Mark II. We want to resolve the crippling designs that happened with the first design and fix them with the second design. And we want to organize the design documentation because we were left with very little as coming into the project. And for long-term goals, we want to demonstrate that our Mark II is functional. We want to keep a detailed record for future groups, and we also want to bring this vehicle into a competition.
So the current state of design, we want to finish what we can on the first prototype. Currently, we have some crippling flaws with it where the previous group thought for their house capping that they would put a grease pocket in it in order to lubricate and seal in the water. Problem with that is that the propellers that we're using cause a churning effect which separates the solid grease from the liquid, allowing the water to flow into the system. Another problem that we have is that there's potential for overheating. We do not have a cooling system inside of it. We do not know how the previous group, if they did anything with the heating or internal cooling, but we know that we do not have a cooling system, so we would have to calculate the heat draw from the motors that we have inside of it, plus whatever electronics that we do put in it for the Mach 2, in order to make sure that nothing overheats, make sure that everything functions properly. The other major problem that we've had is the structure. The group previously thought that going with a sphere for a 6-dimensional sub would be the optimal way of traveling through the water. We have proven that optimizing this isn't as simple as making it a sphere because it is extremely difficult to maneuver things inside of it. It's difficult to attach the housing for the circuitry that we have inside of a sphere dome. And it is also very difficult to mount the propellers in it because we also have to cut holes in our shell in order to actually make the propellers fit through the drive shafts.
So, current state of the design, our Mark I prototype is nearly completed or fully constructed. However, some major technical concerns are slowing progress, like we mentioned. One thing we did like about the current design is that the open beam structure that they have set out works well for motor attachment and component housing. It lends itself very well to 6 faces for 6 motors, so we hope to keep that for our Mark II prototype. However, like we mentioned, the size of the grease pocket being used for waterproofing is of concern due to the design of the prop housing as well as the spherical acrylic shell. As demonstrated, there leaves a large opening for grease, so we hope to reduce that size or pursue other waterproofing methods. Attachment of components to the spheres is problematic as well. We rely mostly on epoxy to attach this. However, like mentioned, that leaves some gaps and potential for failure. And then attaching the cubic center to the spherical shell, the solution agreed upon by the previous group used a lot of silicon and tape, and we're hoping to resolve that to a more permanent solution with a Mark II prototype. There are some alignment issues between the cube and the sphere that lead to stress on the shafts when the motors are running. We hope to simplify the alignment between the center cubic structure and the outer shell of the vehicle with a Mark II. That would reduce the stress on the motor shafts there, as well as make construction of the vehicle easier. Our plan for the project for the remainder of the semester is to conclude our evaluation of the current prototype and decide what we want to carry over to a Mark II and what we want to change. We want to begin the design of the Mark II prototype with the timeline listed below there. We're pursuing a fairly aggressive design strategy here, trying to really get the group in gear. Going to start off designing the base structure, taking into account waterproofing and heat management issues from the very start. Then we're going to be deciding motor placement, choosing a motor type, hopefully something off the shelf to minimize the number of new variables we're introducing to the project. Designing our propeller to most optimally fit the design, and then determine our electricity requirements, hopefully by the end of this semester. And then Brandon will share with you some of our competition goals.
All right, hello again. Our competition goals are adapted from a RoboSub competition that we found on the internet, and this RoboSub competition will have us follow a marked path, pass over and under horizontal markers under the water, which means our underwater sub is going to have to be able to control how the depth of it at any point in time. Also, we'll have to pass through a tunnel and then eventually circumnavigate a vertical marker.
We've had a fairly simple budget this semester, no money spent so far. And then in conclusion, our current group is suffering from a lack of documentation from past designs, so we've had to do a lot of kind of retroactive evaluation of the project. We want to start fresh with a fairly new design and establish a solid foundation for our project, as well as clarify our objectives for the project. The first step of that has been choosing a competition, like we mentioned earlier. All right, do we have any questions?